In this video, we're going to have a look at how to solve algebraic equations step by step by making use of additive and multiplicative inverses. When solving an algebraic equation, you want to rearrange the equation in such a way that you get the variable or unknown alone on one side, because then you have a value for the unknown. For this, we're going to make use of inverse calculations. It helps if you can think about an equation as a balanced scale. The value of the left-hand side is the same as the value of the right-hand side. Therefore, it is important to remember that any calculation that you do has to be applied on both sides of the equation. For example, if you choose to subtract 5 on the left-hand side, the scale will not stay in balance if you don't also subtract 5 on the right-hand side. Next, you also need to remember inverse calculations. Addition and subtraction are inverses, and multiplication and division are inverses. Let's go and have a look at some examples. In the first example, we need to solve the unknown x, and that means we need to get x alone. To get x alone, we need to get rid of the plus 2 on the left-hand side. The inverse calculation of addition is subtraction. So, to get rid of the plus 2 that we have on the left-hand side, we will also have to subtract 2 on the left-hand side. Now, you need to remember that this is like a scale, and to keep the balance, because we subtracted 2 on the left, we also have to subtract 2 on the right. On the left-hand side, we are now left with only x, because plus 2 minus 2 is 0. And on the right we have 12 minus 2, which is 10. So, x is equal to 10. You can also choose to shorten these steps. Because we know that the plus 2 minus 2 on the left will become 0, you can already in the first step only write x is equal to and leave out the plus 2 minus 2. On the right, you will still have your 12 minus 2. Even though you don't really show the minus 2 that you are applying on both sides, in reality we know that it has been applied on both sides. In example 2, we again want to solve x, and that means we want to get rid of the minus 4 on the left-hand side. Again, I'm going to do the inverse operation, and the inverse of minus 4 is plus 4, and that is why I will also plus 4 on the right-hand side. On the left-hand side, we are once again left with only x, because minus 4 plus 4 is 0, and on the right we have that x is equal to 29. Again, you could have chosen to shorten the first step, because you know that minus 4 plus 4 is 0, so you could have also written your first step as x is equal to, and on the right-hand side, 25 plus 4. Then x is still 29. In example 3, if I want to get x alone, it means I need to get rid of the 2 in front. So again, it's important for you to know that 2x means 2 times x. So to get rid of the times by 2 on the left-hand side, I will do the inverse calculation, which means I will have to divide by 2. If I divide by 2 on the left, to keep the balance of the equation, I also have to divide by 2 on the right-hand side. On the left-hand side, I now have 2 divided by 2, which is 1, and that leaves me with only the x. And on the right, we have 14 divided by 2, so x is 7. In example 4, I now have x divided by 6. So, if I want to apply the inverse calculation, I will have to say multiply by 6. But once again, if I multiply by 6 on the left, I also have to multiply by 6 on the right. On the left, we now have 6 divided by 6, so we are left with only the x. And on the right, we have 3 times 6, so x is 18. In example 5, we now have 2 operations. The x is multiplied by 2, and then 5 is added. Here it is important to realize that the order of calculations will now be applied backwards to solve x. I'm going to explain this by using a flow diagram. This flow diagram shows us that we need to take the input value x and firstly multiply it by 2, which will give us the 2x in our equation, and then we need to add 5 to get the output value or y value, and in our case that y value is 29. In our equation we are given the y value or output value, and this is given as 29, and we need to work backwards, firstly doing the inverse of plus 5, which is minus 5, and then the inverse of times by 2, which is dividing by 2, to get our input value or x value. So when writing all of these calculations down, we start by subtracting 5. When you subtract 5 on the left-hand side, to keep the equation balanced, we also have to subtract 5 on the right-hand side. So on the left-hand side, we are left with only the 2x, and on the right-hand side, we have 24. Now we need to get rid of the times by 2, so on the left we will divide by 2, because 2 divided by 2 is 1. Now we also need to divide by 2 on the right, so that means that x is equal to 12. In example 6, we now have the x on the right-hand side of the equation, but because the value of the two sides are the same, it doesn't matter on which side the x is written. In this case, we want to get rid of the times by 4 as well as the minus 7, and I'm going to start off getting the term 4 times x alone. To do this, I'm going to do the inverse calculation of minus 7, which is adding 7, so I will be adding 7 on both sides of the equation. I'm reminding you that you can write the minus 7 and plus 7 on the right-hand side, but because we know that it will add up to give 0, we don't need to write it. Now we have 4x on the right and minus 40 on the left-hand side. So next we want to get rid of the times by 4 by dividing by 4 on both sides. So here our final answer is that x is equal to minus 10. And because we know that the value of both sides will be the same, you could also choose to write x is equal to minus 10.